Alright, so welcome you guys. Today we'll be talking about binomial radical expressions, and everything still applies as though we are doing this in Algebra 1, where we had square root of 8 plus the square root of 27. Okay, the rules still apply. So first you simplify, then you combine. But now let's make this cube root. Okay. So cube root, and I'm going to represent it as cube root for just now. Cube root of 8 plus the cube root of 40. Okay, first off I simplify. Cube root of 8 would be 2. Okay, and then the cube root of 40, I would actually need to figure out which three numbers go into 40. Okay, or what numbers actually go into 40. So I know 8 and 5 do. Okay, and I also know that 4 and 2 go into 8, and then also 2 and 2 go into 8 as well. So what I'm left with is I've transformed 40 into 2 times 2 times 2 times 5. Okay, so this would be cube root of 2 times 2 times 2 times 5. Okay, now when you're dealing with cube roots, you want to look for 3 of a kind, okay, and you want to bring that out. And so what this actually becomes is 2 plus 2 cube root 5. Okay, now the reason why I don't combine any further is because this has a cube root 5, this has no cube root, so I leave it alone. Okay. Alright, just remember, we're not combining, we're not trying to simplify down to, we're not trying to solve for one number, we're actually just simplifying, adding and subtracting, okay? Alright, so make sure you take your time, go through the process, and remember you're looking for more stuff, okay? Now as for multiplying radical binomials, just use FOIL, just like usual. Okay, so this would be 4 times 5, which would be 20. Okay. Alright, and then we would go 4 times 4 root 2, which would be 16 root 2. Okay, so that one's pretty simple. And then we would have 10 root 2, because 5 times 2 root 2 is 10 root 2. And then 2 root 2 times 4 root 2, this one's going to be interesting, it's going to be 8 root 4. Okay, and then you want to simplify. So when you're multiplying, you want to multiply out, and then you want to simplify before you add like terms and everything. Okay. All right. So we're going to combine these two because these both have root 2's. Okay, and so we got 20 plus 26 root 2, and then the last one is going to be 8 times 2. Why does it turn into 2, you say? Because when I'm simplifying root 4, that is, the square root of 4 is 2. So that one's pretty simple. A lot of people miss that, including myself. Okay, so this becomes 20 plus 26 root 2 plus 16. Okay. Alright, and then we get 36 plus 26 root 2. Okay, so that one's pretty simple. Now, if we're multiplying and dividing top and bottom of a binomial, I'm sorry, if we're dividing the radical binomials, you need to multiply top and bottom by the conjugate to go ahead and rationalize the denominator. I had to remember that for a second. It was like, what am I thinking of? Okay, so let's go 3 root 2, okay, is on top. And then let's go root 3 minus root 7. Okay, so what I would need to do is, in order to rationalize this one, okay, obviously I can't divide anything because they're all different roots and everything, and I can't really combine anything because it's all addition and everything. Okay, is I'm going to multiply top and bottom by root 3 plus root 7. The conjugate is just going to be the same as what you have on the bottom, except it's going to be the opposite sign. So root 3 plus root 7. Okay, and so what we're left with is we're going to go ahead and take this 3 root 2 and we're going to distribute it to each part. Okay, and so we're left with 3 root 6, which we can't simplify, plus 3 root 14, which we can't simplify. You can factor out a 3 if you want, but I'm just going to highly recommend, well, shoot, let's factor it out. We might as well practice that. Okay, now down here, this is going to be the fun part, because I'm going to do this all in my head. So root 3 times root 3 is 3. Okay, and that's a rule you should have learned back in Algebra 1. Okay? Now, if you notice, these are both, this is like the ending of when you're doing factoring, when you're doing the perfect square trinomials, or the perfect square, no, not perfect square, difference of perfect squares. Okay? And if you remember, there's no middle term in difference of perfect squares. So this just technically turns into 3 minus root 7 times root 7, which is a 7. So this just turns into 3 minus 7. Okay? Now, whatever happens is whenever you do FOIL, you're going to find out the other two terms cancel out. Okay? So you're left with a negative 4. And so what ends up happening is you get equals, okay, let's factor out the 3 out of the top. I'm running out of room. 3 times root 6. And remember, you cannot combine the roots because even though they are both square roots, you have different numbers inside, and the addition rules work differently. Okay, so we get 3 out of there, and then on the bottom, we get a negative 4. Okay, and some people don't like the negative 4 down there. I'm okay with it. I'm not going to like bust anyone's chops for it, okay? But just remember, you're going to multiply top and bottom by the conjugate, okay? And the conjugate is just the opposite sign. Okay, and adding and subtracting, just remember, simplify first, then combine. Okay? All right, but that's it for binomial radical expressions. If you have any questions, please feel free to ask. Bye.